Good afternoon. This video is devoted to learning about the second equation of motion. At the end of this video, you will be able to derive the second uniform equation of motion and solve problems with this equation. So the question is, should you go home and just watch Judge Judy instead of doing your physics homework? The answer is motion denied. So what I have here is a velocity time graph, and in the moving man PhET activity, you saw that when an object or a man experiences constant acceleration, the graph, when we plot velocity versus time, is linear. Well, if I take a look at this graph here, there's three important points. There's the final velocity, which is at the end of this graph. There's the initial velocity, which here is at the origin. And then, if I wanted to find what's called the average velocity that this object is experiencing, well, that's just in the middle between the final velocity and the initial velocity, or it's the average of those 2 points added together and divided by 2. So if I take a look here, the definition of average is in the middle. So to find the average velocity, all you have to do is add together the final velocity plus the initial velocity, divide by 2, and you'll get your answer. There's another way that we've calculated average velocity, and that's with this equation up here where you have the change in displacement over the change of time equals the velocity. Well, if we set these two equations equal to each other, change in displacement over change in time equals the average velocity, and then do some algebra, we'll come up with the second equation of motion. So what we mean by that is I am going to rearrange this so that I can isolate displacement in terms of time and velocities. To do that, I'm going to cross multiply. So I'll end up with VF in parentheses plus, that's an F, VI times the change in time is going to be equal to 2 times the change in displacement. Last step to isolate displacement is divide everything by 2. And then I can rewrite this equation as change in displacement equals the final velocity plus the initial velocity times the change in time, all divided by 2. That right there is your second uniform equation of motion. We can rewrite it a little differently, like I'm going to do on this slide here. I would pause the video at this point and make sure you have this version of the equation written down into your notebooks, highlighted and labeled second uniform equation of motion. And when you're ready, let's try the example problem. Here's your example problem. A cyclist accelerates from 5.0 meters per second to 16 meters per second in 8 seconds. Assuming uniform acceleration, which is we always have to assume, what distance does the cyclist travel during this time? Well, let's go back here and let's copy and paste the equation we're going to use, although deltas don't transfer, so we'll put them in there. And since we want to find the distance, or the displacement in this case, we can see that the equation has already been rearranged so that distance or displacement is isolated. So I just fill in the blanks. I know what that is, so I can fill it in. Final velocity is going to be 16. Initial velocity is going to be 5. And change in time is going to be 8 seconds. And that's going to allow us to find delta x. So half of 21, because 16 plus 5 is 21, is 10.5. So I'm going to end up with 10.5 times 8. It's going to be delta x. And 10.5 times 8 will get you 84 meters. So that is going to be our displacement, assuming that the cyclist is going in the positive direction from where his origin is. Sig figs, there are 2 in the velocities and there are 2 in the time, so there are 2 in the displacement. That's as simple as it gets. Know that if I wanted to solve for a different variable, such as final velocity, I would have to rearrange that equation to isolate VF, then plug in my variables, and then solve. Hopefully you found this helpful. You're going to be able to solve the assigned problems having to do with the second equation of motion. If you have any questions, do not hesitate to call me over or leave a comment on Schoology. Have a good evening.